Welcome back to the Deep Dive, brought to you by Safety One Source.
Oh, glad to be back.
Today, we're going to tackle something that I think is pretty important, especially for our listeners.
Yeah.
OSHA's scaffolding regulations. We're going deep into the specifics laid out in Standard 1926.452.
Okay.
Because as safety professionals, you know the devil's in the details when it comes to preventing workplace accidents.
Absolutely. Absolutely.
And when I first started looking into 1926.452, I was kind of blown away by just how much is in there.
Oh, yeah. 1926.452 it's a whole world.
Yeah.
You've got requirements for all sorts of scaffolds. Way beyond what most people think about. I mean, we're talking
Pole scaffold.
pole scaffolds.
Tube and coupler. Fabricated frames. Even crawling boards.
Oh, yeah.
Those chicken ladders you see on roofs.
Yeah, those are a fun one.
It just made me realize how much I took for granted.
Yeah.
About how scaffold safety really breaks down.
Yeah.
And I think that's going to be a big takeaway for our listeners today, too.
Yeah, I think it's important to remember that all of this is building on those general scaffolding requirements.
Okay.
You know, in 1926.451,
right,
OSHA is not messing around with, layers of protection here.
So let's start unpacking this by looking at some of the common threads.
Yeah.
Things that apply to multiple scaffold types.
Right.
One thing I noticed is that OSHA really hammers on this idea of not disturbing the existing platform.
Oh, yeah.
When you're moving up to a higher level.
Right. That's a huge one. Yeah. Think about it. You know, you're already kind of in a vulnerable position when you're transitioning between levels. And that undisturbed platform below you really acts like a safety net.
Right.
Prevents you from falling.
Right.
Might seem like a small thing.
Yeah.
But it's really fundamental to safety.
Right.
Especially at that critical moment.
Yeah, it's a good example of how a simple precaution can really go a long way.
Absolutely.
Another thing that kept popping up was bracing.
Oh, bracing, yeah.
Obviously, bracing is important for stability.
Of course.
But OSHA gets into the nitty-gritty.
Yeah.
About specific bracing requirements.
Yeah, and that's because different types of scaffolds, right, are going to experience different types of stresses, different loads.
Right.
And so those bracing configurations, whether it's cross bracing, diagonal bracing, whatever it might be, they're all carefully designed to counteract those specific forces and make sure that the scaffold stays stable.
Okay, so we've laid some groundwork.
Okay.
Now let's get specific.
All right.
And break down the requirements for different scaffold types.
Okay. Sounds good.
I know a lot of our listeners deal with pole scaffolds day in and day out.
Yeah, they're pretty common.
So let's start there. What are some of the must-knows about pole scaffolds from an OSHA standpoint?
Well, I mean, with pole scaffolds, you're working with individual poles, typically made of wood or metal.
Right.
So those connections and bracing points become super important. You got to make sure everything's tied together properly.
I noticed in 1926.452, OSHA is very specific about how those poles are braced. They talk about cross bracing for double pole scaffolds.
Yeah.
Diagonal bracing on both the inner and outer faces.
Yeah.
And it even gets into how that bracing relates to the load capacity of the scaffold.
Right.
Seems like they're really trying to eliminate any chance of lateral movement.
Yeah, exactly. Those requirements, it's all about stability, right?
Right.
Preventing the scaffold from swaying or buckling under pressure.
Yeah, and I noticed that the placement of the bracing is crucial too.
Oh, yeah.
The standard calls out the diagonal bracing should extend across the entire interface of double pole scaffolds.
Yeah.
That are supporting heavier loads. So that ensures that it can handle those loads safely.
Right. It's not going to collapse inward.
Right.
Exactly.
It's interesting how OSHA doesn't just say, brace the scaffold.
Yeah.
They get really granular.
Yeah, they're very specific.
About placement.
Yeah.
Type of bracing.
Yeah.
And how it relates to the specific use case.
Right. It's got to be tailored to what you're doing.
And it's not just about the bracing itself. Yeah. They also get into specifics about how the runners and bearers, those horizontal members that support the platform, how those are installed.
Yeah, so the standard specifies that the runners and bearers, they need to be installed on edge.
Okay.
Which maximizes their strength, right? You're getting the most out of that material.
Right.
And then there's also specific overhang requirements to ensure that the platform is adequately supported on all sides.
Right.
And one thing you'll notice is that the standard forbids splicing.
Between poles for braces bearers or runners.
Okay.
Which ensures that those crucial structural elements are as strong as possible.
There's a lot of thought behind those seemingly minor details, isn't there?
Absolutely.
Every connection.
Yeah.
Every piece of bracing.
Yeah.
It's designed to create a scaffold that can withstand the rigors of a real-world construction site.
That's exactly right.
Now, when we talk about pole scaffolds, especially those made of wood, splicing becomes a critical consideration.
It does. You're essentially creating a joint in the pole, right?
Right.
Which, anytime you introduce a joint, that's a potential weak point.
Yeah. And I noticed the standard is quite detailed when it comes to splicing wooden poles.
Oh, yeah.
It talks about how those ends need to be squared and meet flush.
Right.
How the splice plates need to be a certain size. And even how long that overlap needs to be.
Right.
It almost feels like they're giving you a blueprint.
For how to create the strongest possible connection.
It is a blueprint.
Yeah.
A blueprint for safety.
Yeah.
Think about it, a poorly executed splice could compromise the whole scaffold.
Right.
But by following these requirements, you're essentially turning that splice into a single continuous pole.
Right.
You're minimizing that risk of failure.
It's a good reminder that even when you're dealing with something as seemingly basic as a wooden pole, there's a right way and a wrong way to do things.
Absolutely.
And OSHA wants to make sure everyone's doing it the right way.
They do. They really do.
Now, we've talked about bracing and splicing, but there's one more thing I want to touch on before we move on.
All right.
Height.
Yes.
Height always adds another layer of complexity.
It does.
And OSHA recognizes that.
Yeah.
The standard specifies that once a pole scaffold exceeds 60 feet in height, it requires a design by a registered professional engineer.
Right. It's like they're saying, okay, now things are getting serious.
Right.
At that height, the forces acting on the scaffold become much greater.
Right.
The potential consequences of a failure are much greater.
Yeah.
So you need a pro to look at it.
Right.
A professional engineer can assess those forces.
Right.
Consider wind loads, all those different factors, and really design a scaffold that is specifically engineered to handle those challenges.
So, to sum it up.
Okay.
Pole scaffolds might seem straightforward at first glance.
Yeah.
But there's a lot more to them than meets the eye.
Absolutely.
Especially when you dig into OSHA's requirements.
Absolutely.
Yeah.
It's all about understanding those specific bracing and connection requirements.
Right.
And those splicing requirements.
Right. And that's just the tip of the iceberg when it comes to OSHA's scaffolding regulations.
Yeah, we've got a lot more to talk about.
There's a lot more ground to cover.
Absolutely.
I'm sure our listeners are eager to hear more.
Yeah.
So we'll get to that after a quick break.
Sounds good. All right, let's switch gears a little bit.
Okay.
And talk about tube and coupler scaffolds.
Okay.
These are a little different from pole scaffolds because they offer a lot more flexibility in terms of configuration.
Yeah, tube and coupler scaffolds are kind of like building with an erector set. Right?
Yeah, that's a good way to put it.
You've got those individual tubes.
Yeah.
And then all sorts of couplers that let you connect them at different angles.
Exactly.
It's a very modular system.
Yeah.
Which makes them versatile.
Yeah.
But I can also see how that could introduce some challenges from a safety standpoint.
Yeah, you're right.
Yeah.
That flexibility means you need to have a really solid understanding of the requirements to ensure a safe and stable structure.
Right.
And one of the first things you'll notice, again, is that undisturbed platform rule.
Of course. The golden rule of scaffold safety.
That's right.
It makes sense that it would apply to, pretty much any scaffold where you're working at multiple levels.
Yeah, you always need that secure platform beneath you when you're making those transitions.
Right, right.
OSHA's not messing around with that one.
Now, when it comes to tube and coupler scaffolds, the bracing requirements get a bit more intricate.
They do, they do.
Yeah. I noticed in 1926.452, they talk about this X pattern of bracing.
Yeah.
Across the width of the scaffold. Can you break that down for us? I'm picturing like a giant web of braces, but I'm not sure I'm visualizing it correctly.
It is a bit of a web, but a very deliberate, carefully designed web.
Okay.
So the standard calls for transverse bracing, which forms that X pattern to be installed at the ends of the scaffold.
Okay.
And at specific intervals, both horizontally and vertically.
Okay.
And this creates this sort of grid-like structure that helps resist forces from multiple directions.
So it's like they're anticipating all the ways that scaffold could potentially move or twist.
Yeah.
And then adding bracing to counteract those forces.
That's a great way to put it.
Okay.
And then in addition to those transverse braces, you've also got longitudinal bracing that runs diagonally across the inner and outer rows of posts.
Okay.
And this helps prevent the scaffold from swaying or buckling lengthwise, especially when you're dealing with longer scaffold spans.
It's like they've created a safety net within a safety net.
Yeah.
With all these braces working together to keep everything stable.
Exactly.
And the placement of those braces is just as important as the type of bracing.
Absolutely.
Right.
Yeah.
They need to be as close as possible to where the bearers, which support the platform, connect to the posts or runners.
Right. You got to make sure that those loads are transferred effectively.
Right.
And that there aren't any weak points.
So it's not just about connecting the pieces.
Right.
It's about connecting them in the right places.
In the right place.
To maximize that strength and stability.
Exactly. Yeah.
And while we're talking about connections, we need to talk about couplers.
Couplers. Oh, yeah.
Those things that hold the whole system together. OSHA has some very specific requirements.
They do.
About the types of couplers that can be used.
Yeah.
I was curious about that. Are all couplers created equal?
No, they are not. The couplers that are used in tube and coupler scaffold, they have to be made of a structural metal.
Okay.
Something strong enough to withstand the stresses of a scaffold.
What about those gray cast iron couplers I've seen around?
No.
Are those okay to use?
Those are a no-go.
Okay.
Gray cast iron is brittle.
Okay.
And it's simply not strong enough to handle those loads. Right. Especially in a dynamic environment like a construction site.
Right.
Where things are moving and shifting all the time.
It's amazing how much thought goes into every little detail of these scaffolds.
It really is.
I'm starting to see scaffolds in a whole new light.
That's good. That's good.
Yeah.
And as we saw with pole scaffolds, that attention to detail becomes even more important as the height of the scaffold increases.
Right.
Once a tube and coupler scaffold goes above 125 feet, a registered professional engineer needs to sign off on that design.
There's that 125-foot mark again.
There it is.
It seems to be the point where OSHA is like, all right, now we need to make sure an expert has reviewed this to ensure that it's safe at this height.
Exactly. As scaffolds get taller, the forces acting on them, they increase exponentially.
Right.
And the potential consequences of a failure, they get a lot more severe.
Right.
So you need that expertise. You need a structural engineer.
Okay, so we've covered pole scaffolds and tube and coupler scaffolds.
We have.
Now, I want to talk about a scaffold type that I think is probably the most common on construction sites.
Yeah.
Fabricated frame scaffolds. I feel like I see these everywhere.
Yeah.
But I'm betting there are nuances to these that I've never even considered.
Oh, I think you'd be surprised. There's a lot more to them than meets the eye.
Yeah.
You know, they might seem simple at first.
Yeah.
You got those pre-engineered frames and panels.
Right, right.
But as a safety professional, you really need to be aware of those details.
Okay, well, I'm ready to dive into those details.
Right.
Let's uncover those hidden complexities of fabricated frame scaffolds.
So before we get into the specifics, I just want to point out that undisturbed platform rule applies here as well.
Of course. It wouldn't be a deep dive into scaffolding safety without a mention of that golden rule.
There it is.
It's starting to feel like a mantra at this point.
A good mantra to have.
Yeah.
It applies just as much to fabricated frame scaffolds as any other type.
All right. Undisturbed platforms, check. Now let's talk about bracing.
Okay.
I've always assumed that those cross braces connecting the frames were the main thing to worry about.
Yeah.
But I'm sure there's more to it than that.
Oh, there always is.
Yeah.
You're right.
Okay.
Those cross braces, they are essential.
Okay.
But there's a lot more nuance to how they're used in fabricated frame scaffolds.
Okay.
So the standard requires cross bracing, either horizontal or diagonal, or a combination of both to secure the vertical members of the frames and panels.
Okay.
And these braces, they can't just be any old length either.
Oh, okay.
They need to be the right length so that they automatically square and align the vertical members.
So it's like built-in quality control.
Yeah, exactly.
The braces themselves help ensure that that scaffold is plumb level and square.
You got it.
And speaking of assembling things correctly, we need to talk about how those frames and panels are joined vertically.
Right. So you'll often see them connected with those coupling pins or stacking pins, and that's definitely a common method. And it's specifically mentioned in the standard.
Okay.
But the standard also allows for equivalent means.
Okay.
As long as that connection is secure.
Okay.
And it prevents the frames from separating vertically.
So it sounds like there's some flexibility there.
Yeah.
As long as you're achieving that same level of security.
Exactly.
Okay.
However, there's an additional requirement when there's a chance of uplift forces.
Okay.
Something that could potentially displace those end frames or panels.
Like on a really windy day, for example.
Exactly.
Okay.
So in those situations, the frames or panels need to be locked together vertically.
Okay.
Using pins or an equivalent method.
So it's like an extra layer of protection?
Yeah, it is.
To prevent those components from separating.
Exactly.
Okay, it makes sense.
Yeah.
It's all about anticipating those forces and ensuring the scaffold can withstand them.
That's it.
Now let's talk about those brackets that are often used to support cantilevered loads on fabricated frame scaffolds. You know those brackets that jut out from the side?
Yeah, I know what you're talking about.
Yeah.
Those can be tricky.
I've always wondered about those. They seem a bit precarious to me.
Yeah.
Especially when you see people loading them up with heavy materials.
Yeah, that's why there are specific rules about how those can be used.
Okay.
So first of all, they have to be seated correctly.
Okay.
The side brackets need to be parallel to the frames.
Okay.
And the end brackets need to be at a 90-degree angle. No bending or twisting allowed.
So it's all about making sure those brackets are properly aligned.
Yeah.
And providing that maximum support.
Exactly.
Okay.
And here's a crucial point.
Okay.
Unless the scaffold has been specifically engineered to handle other types of loads, those brackets are primarily intended to support personnel.
So if you're going to be stacking heavy materials on those brackets, you need to make sure...
You have to make sure an engineer has looked at it.
An engineer has signed off on it.
Yes.
Okay.
Exceeding that personnel load limit without an engineer's approval, that's a recipe for disaster.
Right.
You could end up with a collapsed scaffold.
Yeah.
Serious injuries.
That's a really important distinction.
It is.
Yeah, I think a lot of people might assume that those brackets are just generic load-bearing platforms. But it sounds like there are very specific limitations.
Absolutely.
On how they can be used safely.
Yeah.
And just like with the other scaffold types we've discussed, when you start getting into those taller scaffolds, the need for professional engineering oversight becomes even more critical.
It does.
The standard specifies that any fabricated frame scaffold over 125 feet in height needs to be designed by a registered professional engineer.
125 feet, there it is again.
Again with the 125-foot rule.
The golden number.
It's like the golden number for scaffold safety.
It is.
Yeah.
Now we've covered those three main types of scaffolds in quite a bit of detail.
Right.
Pole scaffolds, tube, and coupler scaffolds, and fabricated frame scaffolds.
Right.
But OSHA 1926.452 doesn't stop there.
Okay.
It covers a whole range of other more specialized scaffold types, each with its own unique set of requirements.
Yeah, and I'm really curious to hear about those more specialized types.
Okay.
It's fascinating to me.
Yeah.
How many different ways there are to build a scaffold. Depending on the task at hand.
There are. Well, get ready.
Okay.
Because we're about to cover a lot of ground.
Okay, bring on those specialized scaffolds.
Okay. You ready for a whirlwind tour?
I am. Let's do it.
All right. First up, we have plasterers, decorators, and large area scaffolds.
Okay.
These are often built using components from other scaffold types.
Okay.
So a lot of what we've talked about already applies here.
Right.
But you got to make sure you're applying the right rules based on, what components you're actually using.
So it's like a mix and match.
Yeah.
But you still need to be aware of those underlying safety principles.
Absolutely. Then we've got bricklayers, square scaffolds.
Okay.
Pretty much what they sound like, those square scaffolds used for bricklaying.
Right.
And OSHA is very concerned about those tiers being stable, especially as they get higher.
Okay.
So you've got things like gusset plates to reinforce the corners, diagonal bracing on all sides.
Okay.
And specific rules for how you stack those upper tiers to prevent them from shifting or collapsing.
It makes you think of like those Jenga towers.
Yeah.
Where one wrong move and the whole thing comes down.
That's a good analogy.
Yeah.
And speaking of things that can topple over, let's talk about horse scaffolds.
Okay.
Those are those portable A-frame type scaffolds.
Right.
Seem pretty simple, right?
Yeah.
But even with these, OSHA wants to make sure they're not going anywhere.
Right.
They limit the height.
Okay.
And the legs have to be nailed down or otherwise secured.
So no rogue horse scaffolds allowed?
No rogue horse scaffolds.
Okay, what about form scaffolds and carpenter's bracket scaffolds?
Oh, yeah. Those are another interesting one.
What are the key takeaways for those?
Well, with these, it's all about how securely those brackets are attached, whether it's to formwork or a wall.
Okay.
OSHA lays out all sorts of approved methods. You know, you've got nails, metal studs, welding, bolts.
Right.
But the point is, those brackets can't come loose.
Right, yeah.
Or you're looking at a potential collapse.
Right.
Solid connections are crucial.
Especially when those brackets are supporting workers and materials high in the air.
Absolutely.
Now, I know we have some listeners who work on roofs.
Oh, yeah.
So let's talk about roof bracket scaffolds.
All right. Roof bracket scaffolds.
Those are the ones where the brackets attach directly to the roof.
Right.
And OSHA has specific requirements for these, too.
Well, they do.
Okay.
First off, those brackets have to be designed to match the slope of the roof so that the platform is level.
Right.
Makes sense, right? Yeah. And then they need to be anchored securely.
Okay.
Either with nails or, if you can't use nails, they say you got to use sturdy rope.
So it's all about making sure those brackets stay put and don't slide down the roof.
Exactly.
Right.
And while we're on the topic of things that could slide or shift, let's move on to outrigger scaffolds.
Okay.
These are the ones where you have beams extending out from a building to support a suspended platform.
Okay, those sound a bit more complex.
Yeah, they are a little more complex, which is why there are so many requirements for them.
Right.
OSHA gets into things like the length ratios for those beams to ensure stability, the need for secure bearings, and how that entire supporting structure needs to be braced to prevent horizontal movement.
So it's not just about the platform itself.
Right.
It's about that whole system of beams and supports.
The whole system.
That hold it in place.
That's right. Next up, pump jack scaffolds.
Okay.
These are pretty cool.
Yeah.
They use adjustable poles that you raise and lower with a pump jack mechanism.
Yeah, I've seen those in action. It's pretty slick how they work.
It is.
Yeah.
But as always, OSHA has some key safety points.
Okay.
The big one here is that each pump jack bracket needs to have two separate gripping mechanisms.
Okay.
That redundancy is designed to prevent any failure or slippage.
Right.
That could cause the scaffold to drop suddenly.
2 is always better than 1 when it comes to safety mechanisms.
Absolutely. Now let's talk about scaffolds that use ladders as their primary support.
Okay.
Ladder jack scaffolds.
Okay, yeah.
OSHA is very clear about the limitations on platform height for these.
Sure.
And of course, those ladders have to meet all the general ladder requirements.
Right.
Plus, they need to be secured or have devices to prevent them from slipping.
Right. You don't want those ladders kicking out from under the platform.
You do not.
Similar to ladder jacks.
Yeah.
There are window jack scaffolds.
Yes.
Which use a bracket that attaches to the window opening.
Mm-hmm.
But here's the thing.
Yeah.
These are super specific.
They're
only for working at that window.
Right.
Where the jack is placed.
Exactly.
So you can't use them to span between windows where it's a general purpose scaffold.
Nope. They have a very specific use case.
Right.
Okay. Are you ready for the one you've been waiting for?
Crawling boards.
Crawling boards, yes.
Also known as chicken ladders.
A chicken ladder.
I'm picturing like a plank.
Yeah.
With cleats for gripping, just precariously perched.
That's pretty much it.
Yeah.
And while they may look a little nerve-wracking, OSHA does have rules to make them as safe as possible.
Okay.
So they have to extend from the roof peak to the eaves and be securely attached with ridge hooks or something equally strong.
You definitely need a good sense of balance and a head for heights to work on one of those.
Absolutely.
Yeah.
Now, for folks who are more comfortable with their feet firmly planted on ladders, there are step, platform, and trestle ladder scaffolds. These use ladders as their base. And as you'd expect, there are limitations on the platform height.
Right.
And those ladders have to meet all those general ladder requirements we talked about, including being secured against slipping.
It's like OSHA took the idea of a basic ladder.
Yeah.
And was like, okay, how can we turn this into a safe and stable platform?
That's a great way to put it.
Yeah.
Now let's get into the world of suspended scaffolds.
Okay.
First up, single point adjustable suspension scaffolds.
Okay.
These are held up by a single rope. And ideally, that rope should be vertical.
Okay.
But OSHA does allow for non-vertical situations
Okay.
if you meet certain conditions.
So there are exceptions to the rule.
Yeah.
But they come with very specific safety stipulations.
Right. You need a qualified purser to design the rigging.
Okay.
The scaffold has to be accessible for rescue.
Right.
The rope needs to be protected from chafing.
Okay.
And you got to prevent it from swinging into anything.
It's all about mitigating those extra risks that come with a non-standard setup.
Absolutely. Now, for a scaffold type, that's pretty iconic.
Okay.
Bosun's chairs.
Okay, yeah.
You know those suspended seats used for working at heights?
Right.
For these, OSHA really gets into the nitty-gritty about the strength and durability of the tackle, the seat sling, the materials used.
I could see why that would be critical when you're literally hanging from a single point.
Absolutely.
Next, we have 2-point adjustable suspension scaffolds.
Okay.
Or swing stages, as they're commonly known.
Right.
These hang from 2 ropes.
Yeah.
And the platform width is limited to 36 inches.
Mm-hmm.
Unless it's specifically designed to be wider.
Right.
And still stable.
And still stable, yeah.
There are also rules about how you fasten it to the hangers.
Yeah.
And the size of the blocks and sheaves for the ropes.
Yeah. Lots of details.
So again, it's all about stability.
Yeah.
Ensuring that platform isn't going to tip or swing unpredictably.
Exactly.
And the swing stages have a bigger cousin.
They do.
Multi-point adjustable suspension scaffolds.
Yes.
Which can hang from more than 2 points.
That's right.
If you're bridging multiple scaffolds together, which you can do under the right conditions.
You can, yeah.
Those connections have to be articulated.
Right.
And you need to make sure your hoists are strong enough to handle the load.
They gotta be beefy.
So you're basically creating a network of suspended platforms, but with extra safety considerations built in.
That's right. Now for a scaffold type with a very descriptive name, catenary scaffolds.
Okay.
These use wire ropes that are suspended between 2 points in this catenary curve to hold the platform.
Okay.
And OSHA has rules about where you can place the platform, the safety hooks you need to prevent it from slipping off the ropes.
Right.
And they specifically forbid splicing those wire ropes between the anchor points.
So it's all about ensuring those ropes are strong. And continuous.
Continue one anchor to the other.
That's right.
Okay.
Now imagine a scaffold on water.
Okay.
That's a float ship scaffold.
Okay, yeah.
It needs at least 2 bearers supporting the platform.
Okay.
Secure rope connections to prevent it from shifting.
Right.
And a specific arrangement of ropes to keep it stable.
Wow, that's one I hadn't even considered before.
Yeah, there's a lot of them out there.
Yeah.
Then there are interior hung scaffolds.
Okay.
Which are suspended from a roof or ceiling beams.
Okay.
And before you even think about putting one of these up, you got to inspect those structural members.
Right.
Make sure they can handle the load.
Right.
And just like with other suspended scaffolds, those connections between the ropes, cables, and supports have to be absolutely bomb-proof.
It's like a hanging jungle gym.
Yeah.
But with much higher stakes if something goes wrong. Absolutely. Moving on to needle beam scaffolds.
Okay.
These use horizontal beams, called needle beams, that are supported by ropes or hangers to hold the platform.
Right.
And one end of a needle beam can actually be supported by a permanent structural member.
Okay.
But the key is those connections have to be designed.
Okay.
So the beam can't roll or shift out of place.
So it's like building a bridge to support the platform, but with extra attention to those critical support points.
Exactly. And speaking of multiple levels, we have multi-level suspended scaffolds.
Okay.
As you might guess, these involve multiple platforms at different heights.
Okay.
And each level has to have its own set of support lines.
Okay.
Rigged and anchored separately.
So safety in layers.
Safety in layers.
Just like with all of these OSHA regulations.
Absolutely.
All right, let's wrap things up.
Okay.
With a scaffold type that's probably pretty familiar.
Okay.
Mobile scaffolds.
Mobile scaffolds, yeah.
Just because they're on wheels?
Yeah.
Doesn't mean they're off the hook when it comes to bracing.
No, no, no.
They still need cross bracing or diagonal bracing.
Right.
To prevent racking or collapse.
Absolutely. You can't just assume because it's on wheels, it's stable.
So they're mobile, but they still need to be structurally sound.
Exactly.
And those wheels need locks.
Yes.
To keep them from moving when you're working on the scaffold.
Absolutely.
And OSHA also has rules.
Yeah.
About how you move them safely.
Yeah.
Like limitations on manual force.
Yeah.
And the power systems that you can use.
Right.
Mobility definitely introduces a whole other set of safety considerations.
It does. It does.
All right, 2 more.
Okay, 2 more.
Repair bracket scaffolds are pretty self-explanatory.
Pretty much, yeah.
They support platforms for doing repairs.
Right.
But OSHA is very specific about that wire rope.
Oh, yeah.
That holds the brackets. It has to be at least a 1/2 inch thick.
At least.
And each bracket needs a locking device to prevent it from detaching.
You don't want those brackets coming loose.
Again, it's all about that secure connection point.
Exactly.
Right.
And last but not least, we come to a type of scaffold that might surprise you.
Okay.
Stilts.
Wait, stilts?
Stilts, yeah.
Like what you would see in a circus?
Yep. Those stilts.
And they consider those scaffold?
Well, they're not technically a scaffold themselves.
Okay.
But OSHA does have rules about using them on scaffolds.
Okay.
Specifically, large area scaffolds.
Okay.
And if you're using stilts on a scaffold that has guardrails, those guardrails have to be raised to account for that extra height.
So it's like OSHA is saying we're covering all the bases, even if those bases are a few feet higher than usual.
That's right. And that, my friend, concludes our whirlwind tour of scaffold types.
That was quite a journey.
It was.
Yeah, from pole scaffolds to chicken ladders to stilts. We covered a lot of ground today.
We did. And we only scratched the surface.
Right.
This standard is packed with details.
Yeah.
I encourage everyone to go read the full text.
Right.
Which we'll link to in the show notes.
Absolutely.
Yeah.
And as always, Safety One Source is here to support you.
Of course.
We've got tons of resources on scaffold safety, including training materials, products to keep your work sites compliant, and even expert consulting if you need some extra guidance.
So as you go back to your work sites and put on those hard hats, remember what we talked about today.
Right.
Take a close look at the scaffolds you're using. Think about those specific OSHA requirements.
Right.
And never cut corners when it comes to safety.
Wise words. Thanks for taking this deep dive with us.
My pleasure.
Until next time, stay safe out there.
You too.